Alright, students, today we're going to be talking about chords. So the first thing that we have to do is create a circle with a radius of 6 centimeters. So we're going to take our compass, move it out to 6 centimeters, and create a circle that has a radius of 6 centimeters. Okay, so our radius is 6 centimeters. I'm just going to create a little dashed line to remind myself that this is 6 centimeters. Alright. Then we're going to create a diameter. We have to go through that center point and mark the size point B and point C. So now remember, our diameter is twice the radius. So that means that's 2 times 6 gives me 12 centimeters is my diameter. Then it says we're going to create a intersection 4 centimeters along this diameter. So we're going to move our compass to 4 centimeters. And then we're going to create a tick mark because we're using our compass as a ruler. So I've got 2 tick marks here, and we're going to label these points. On AB we're going to call this J, and on segment AC we're going to call this K. Now we're going to create a perpendicular line to segment AB. So to do this, you're going to need to move your compass all the way to the bullseye. Move your thing all the way to the bullseye because we don't have a lot of room. Now you should remember how to do a perpendicular line because we're going to create a perpendicular bisector here. We're going to create 2 tick marks, and since we're doing the same thing for both lines, I'm not going to move my compass. I'm going to create 2 tick marks here. Alright, so now I have equal distance between them. I'm going to line my bullseye up on the red dot, and I'm going to move my fang so it's between the point and my red dot here, or my red line, sorry, and create a intersection. So now I have 2 arcs. Where those 2 arcs intersect is where I'm going to draw my line. I'm going to draw my line through those intersections to the circle, and we're going to label these point E and point D. We're going to do the same thing on the other side. Over there at point K, we're going to create a perpendicular line. So doing the same thing, I'm going to create 2 arcs using these 2 red lines. Same thing as what we just did. Where those 2 lines or those 2 arcs intersect, draw a line through and label these points H and G. Okay, so remember that from A to J was 4 centimeters. I'm going to write that on here. And from A to K was 4 centimeters. And then from J to B was 2 centimeters. And from K to C is 2 centimeters. Because remember, my radius is 6 centimeters. So 6 minus 4 is 2. Alright, so now it's asking me, okay, what is the length of DE? Well, we can use our compass as a measuring tool and use it like a ruler, and this guy is 9 centimeters roughly. So we can say that it is roughly 9 centimeters. So DE is roughly 9 centimeters. And then we can go measure point for our segment HG. So same thing, we're going to use our compass as a ruler, and that's 9 centimeters. So both of these guys are congruent, and these guys are what are called chords. So a chord is a line that is perpendicular to a radius. And it intersects, that perpendicular line intersects the circle at 2 points. Now, what we've shown here so far is that if I have two radiuses and I draw a perpendicular line at the same point away from the center, so these two are 4 centimeters away, these two perpendicular lines, their lengths are going to be congruent. That's the important part that we're remembering today. So now, if I want to figure out what the measurement of GAH is, so GAH, so this is an angle right here, I got to create those angles. So I'm going to go ahead and draw a line through A to D, so that's another diameter here, and from E to G, which is going through A. Okay. So now I have angle GAH. Well, I can use my protractor here, and we're going to measure that guy. So this is roughly 96 degrees right here. This whole thing is 96 degrees. Well, let's measure the other one over here. Let's measure, so this was 96 degrees. So let's measure DAE. So again, this guy's 96 degrees, which should make sense to you guys, because if they're the same distance here, then these chords have to be congruent. Well, then that means that these angles have to be congruent too, because if these angles are congruent, if I cut them in half, because this is going to be, these segments are the exact same length, so these guys are congruent. So this whole thing was 9, so that means this guy is 4.5. That means this guy is 4.5. I have a right angle, so I can have angle side side, which I can't use, but I can use, let's see if I know what this angle is right here. What's half of 96? Which is 48. So just this angle right here, it's going to be 48 degrees. So that means I know what this angle is here, because I can take 90 minus 48, which is going to give me 42. So now I have angle, angle, side, and angle, angle, side. So that means that these two triangles are congruent, and I have the same measurements over here. So this guy is also 48 degrees, and this guy right here is also 42 degrees. So these guys are congruent. So all 4 of these triangles are congruent. So if you have a chord that is the same distance from the center on a radius, it doesn't matter where, because if I move this guy, it's not going to change the measurements of this triangle. It's going to stay the same. What's important is if it's the same distance from the center of the triangle on a radius, then these two chords are going to be congruent. And then last but not least, remember our circumference is 2 pi r, so I got 2 pi times my radius, which is 6, so this guy is 12 pi. Remember that radius is a multiplier, so it goes 6x bigger.